Hi, I'm Guang, 50 years old. In this lesson on limit calculation, we are taking a look at this type of example where we are given the function of the limit. The result of the limit. Well, result most of the time, since you might have other cases where your coefficient or constant that you have to determine is the result. But most of the function, you are given what it is already. So, in this example, we do have limit x approaches to infinity. Ax squared minus bx plus 1 divided by 3x plus 2 is equal to 5. So we need to find the values of a and b. Now, we will be using 3 different methods to solve this example here. So let's start with method 1. So our first method is going to be factorization. Alright, so factorization. Again, there could be a few different ways to factorize it, but this example is none like what we have done before, since in previous examples we did have 0 over 0 form, which means you could try to factorize whatever you have in the denominator out in the numerator. But in this case, we have an infinity over infinity form, which, well, you can't really just have infinity divided by that infinity once again, unless it really is that special of a case, but then the term behind you have to determine once again. Right, so in this factorization, what you can do is either take out a 1 over 3 first, or you can just directly try to manipulate whatever you have in the numerator, alright? So, when you take out 1 over 3, your denominator becomes x plus 2 over 3, which means in the numerator you have a x plus 2 over 3. But wait, we do not have this 2 over 3 ax term at the beginning, so we'll have to subtract it. Well, we're going to see minus 2 over 3a, then plus b multiplied by x, and then add 1. Alright, so this is the first step you can make to factorizing whatever we have. Next, we are going to essentially use partial fractions to separate them, and you're going to see ax minus. So next step we need to do, once again, change this x into x plus 2 over 3. But since you added another term here, you're going to have to subtract it away once again. And subtracting this, what you'll see is minus 4 over 9a minus 2 over 3b. Now, why does this 1 from positive 1 become negative 1? Well, you just have to look at the front. We took out a negative from both of these, alright? So essentially, this is what we are going to see. Next step, once again, you can take them out. We're going to have 1 over 3 limit x approaches to infinity, and we're going to have ax minus 2 over 3a plus b, then plus 1 plus 4 over 9a plus 2 over 3b, then divided by x plus 2 over 3. Right, so this is what we are seeing, and this is equal to 5. So what can we determine from this step? Well, what you'll realize is you have an ax term, you have a constant term, and you have a term that essentially is just 0. So this term you can just pretty much ignore. But the ax term, which means a will actually have to be equal to 0 in order for this to not become infinity or negative infinity if you have a that is negative. But we have a fixed value, not infinity or negative infinity. So a has to be equal to 0. And since a is equal to 0, you take a look at your second term, which is the constant part. And you get negative b, or negative 1 over 3b is equal to 5. And thus b is equal to negative 15, right? So this will be the result you get with this method of factorization. Right, so that is our first method. Let's take a look at what other kind of method we can use. So, method 2. We will now look at, well, the conversion between infinity calculation and infinitesimal calculation. So since this is an infinity over infinity form, you can choose to convert between infinity calculation and infinitesimal calculation, alright? Right, so this is what you're going to see for your second method. Now, in this method, what you're going to do is divide whatever you have here, both of them, by x, alright? So what are you going to see when you divide both of them by x? And also you might be wondering, why x, not x squared or something, right? Okay, so if you divide both of them by x squared, yes, you do get a constant in your numerator, but your denominator now becomes infinity. But then you can also try to deduce something from there. Or alternatively, if you can just see it, what you realize is when you divide them by x, so here you have a 3 plus 2 over x. If you have divided by x squared, well, the other terms just seem to be 0, which is a constant over 0, which is not right, isn't it? But in this case, although it is an infinity over a constant, what you will actually realize is you can remove the infinity by letting a be equal to 0. So from this first step, you can find that a is equal to 0, but if you divide both of them by x squared, you can't deduce that a is equal to 0, alright? So from this step, we can continue to look at it. Or if you can already find it, it is already obvious that the answer for b. So why is that so? This is equal to 5, right? But if a is equal to 0, they're just going to have negative b divided by 3 is equal to 5. So b is equal to negative 15, alright? But of course, then you can write it. Once again, this is equal to negative b over 3, which is equal to 5. So that is pretty much what you have in the second method, alright? So, our third method time. Now in our third method, what we will see is the L'Hopital's rule. So, the L'Hopital's rule, since it's an infinity over infinity form, you can use the L'Hopital's rule. And of course, it is continuous differentiable, alright? So, when you differentiate once, you're going to have 2ax minus b divided by 3. Well, from this step, you could pretty much already determine what you're going to have. Why is that so, you might wonder? It is pretty much the same as the second method, but just using a different method to find that a is equal to 0, alright? Since after the L'Hopital's rule, you'll realize you have some kind of an infinity over a constant. Well, it is infinity when a is non-zero, alright? So if a is 0, well, you'll get your constant, which has to be the case since you're given the answer is 5. And with a is equal to 0, b will be easily determined since negative b over a is equal to 5. So b is equal to negative 15, alright? So that is pretty much it for this example, where we get A is equal to 0, B is equal to negative 15. Right, so let's take a look at all of these three methods again. In the first method, you have factorization, which is probably the most complicated out of these three. But factorization, you just have to reduce it to a form where you have infinity plus slash minus some kind of constant, and then the rest is 0. Then from there, you can determine that the coefficient of the term with infinity is 0. Then since there's two constants and you already know one of them, you can determine the other. Right. So then method 2 and method 3 are similar in terms of trying to find that infinity term, making all the others a constant term. Then the coefficient of the infinity term, once again, becomes 0. Alright? So that's pretty much it for these three methods and this example. I hope that you're clear of it so far. I'll be ending this here, and thank you for your watching.